In number 12, we see that a landscape architect is planting a flower garden. She decides to arrange the garden in rows, and for each row, the number of plants will increase by 3. She has a total of 70 plants and wants to end up with 5 rows. How many plants will be on the first row? So, on the first row, we're going to have X number of plants, because I don't know how many plants are on the first row. But on the second row, it says the number of plants increases by 3. So I'm going to take the X, unknown number of plants, and add 3 to it. On the next row, there are 3 more than the previous row. On the next row, there are 3 more again. And on the fifth row, which is all that the gardener wants, we have 3 more still. So, as you know, we could have written this a lot more simply. The first row is X. The second row is X plus 3. The third row we can write as X plus 6. The fourth row we can write as X plus 9. And the last row we can write as X plus 12. That's just combining some like terms. Now, all together, we want to have 70 plants. So we need to add all this together and see what we need X to be to get a grand total of 70. Now, we already know we have this many plants from the description the gardener gave us. How many is that total? Well, that's going to be 30 plants total. So we already have 30 plants, which leaves us with 40 more. So all of these together has to be 40 plants because this group is 30. So 5x is equal to 40 plants. 5x equals 40. That means that x must be 8. So on the first row, we have 8 plants. Now in number 13, it says solve for x if you have an equation 6 raised to the 3x equals 30. If you have an x trapped in an exponent like we do here, in order to get it out, we have to do a log, because the opposite of an exponent is a log. So remember, the log has the same base as the exponent does. So we're going to have log base 6. Then we're going to go around, we get a 30 next, and finally we get a 3x. So log base 6 of 30 equals 3x. Remember, you can put this into your calculator as the log of 30 divided by the log of 6. That's called the change of base rule. So you can put that right in your calculator, and you get 3x equals that. Log of 30 divided by log of 6 is approximately 1.898. So now I just have to divide that by 3. And so I get 0.6327. So for number 13, x is approximately 0.6327. In number 14, Alicia's given $500 for her birthday and she puts it into a savings account that will earn interest. The amount of money is given by the function below, where A represents the amount, T represents the time in years. What is the range of the function? Remember that the range of a function is all the y values. So you can look at a graph of this function, but it's going to be some pretty large numbers, so you might have to zoom out a little bit. When you do that, you're going to see a function that looks something like this. It's an exponential function, and all exponential functions have what we call a horizontal asymptote. That means that there's a horizontal line that this function is never going to go below in this case. And that horizontal line for this one is going to be y equals 0. So the range of the function is going to go from 0 all the way up to infinity. And to write that in interval notation, we would do 0, infinity. The reason I use parentheses here is because we never actually get to 0. Asymptotes are never touched or crossed. And infinity over here, because we're going up forever and ever and ever. We don't use parentheses ever when we have infinities.